So we're on question number 5. They want us to draw a graph of this function by first placing the horizontal and vertical asymptotes and then an additional point on the graph. So how do we find the horizontal and vertical asymptotes? Let's start right here. I'll start with the horizontal asymptote. So remember, on a graph, a horizontal asymptote would be like, a line of approach. It's a line. It might come from above or below, but it's a leveling out line. It's like as you go way off towards infinity on the x-axis towards infinity, does the graph tend to level off. So what you do is you just let x be 100. Way over here to 100, and plug it in and see what you get. So what do we get? We get y equals minus 2 times 100 plus 6 over 2 times 100 minus 2. So what does y equal? That would be minus 200 plus 6 over 200 minus 2. Can you tell that this 6 and this minus 2 don't matter at all? And this is basically minus 1. Right? Because the 200 is so much bigger than the 6 or the 2 that they virtually don't matter. I mean, if you technically did it on your calculator, to be exact, it would be minus 194 over 198. It would be, basically, here, I'll do it real quick on my calculator. It would be 0.98 negative. So it's basically negative 1. Do you see? It's super close to negative 1. Why? Because these smaller terms don't matter when we head towards infinity. When we go to 100, and we're only at 100, let alone go to 1,000, a million, a billion, a trillion. So, in other words, it's headed towards negative 1. The graph is going to head towards a horizontal asymptote of negative 1. That's because all that matters, another way you could say it, is this term and this term are all that matter as you go way off to the right. All the terms matter, if you're right in this area close to 0. But if you're going way over to the right, 100, 1,000, a million, way off to the right, head towards infinity, yes, all that's going to matter when you plug in a super big x number like that, the 6 and the minus 2 drop off. All that matters is the most powerful term on the top and the bottom. These x's cancel, and so do the 2's. It's negative 1. Y is going to get really, really close to negative 1. So that's the horizontal asymptote. That's the leveling off of the graph as we go way off to the right and the left. So negative 1, so right here at negative 1 is the horizontal asymptote. That's the leveling off that the graph will eventually do way off to the right and way off to the left. Now, how about the vertical asymptotes? How do we find a vertical asymptote? Well, vertical asymptote is like a vertical dotted line. It makes the graph go up to infinity or down to negative infinity, right? The y value goes to positive infinity or the y value goes to negative infinity. Well, here's the equation: y equals minus 2x plus, let me put it back the way it was, minus 2x plus 6 over 2x minus 2. What's going to make that whole fraction go to infinity? Positive or negative infinity, doesn't matter. Some kind of infinity. How does a fraction go to infinity? Only if the bottom is 0. Doesn't matter what's on the top. If the bottom is 0, 0 goes into any number an infinite amount of times. Right? A fraction means divide. You know that. Like 10 divided by 2 is 5 because 2 goes into 10 5 times. So what's 10 divided by 0? How many times does 0 go in there? It goes in there forever and ever and ever. Infinity. Now 0 on the top. What if you have 0 on the top? That's just 0, right? If I say last night I had 0 thirds of the pie. That's just a weird way to say you ain't no pi. So we know 0 in the top is just 0, but 0 in the bottom, that's infinity. So that's how you get infinity. That's how you get a vertical asymptote. That's how you get the y value to go to infinity. The whole fraction goes to infinity if the denominator equals 0. So you take the denominator and you say, what's going to make the denominator equal 0? What's going to make the denominator equal 0? Because that'll be what makes the function go to positive infinity or negative infinity. Well, jump the 2 over, or add. You just add 2 to both sides. Same thing, whatever. And you get positive 2. Divide by 2. And what's the answer? What makes it go to x is 1? So x is 1 is where we have a vertical asymptote. So that means, let's go put that on there, that x is positive 1. Right there at x is positive 1 is the vertical asymptote. So we got the 2 asymptote lines on this one. And so that's the first thing they want you to click. They want you to, when you use the graph making tool, your first click is right there, the center of the crosshairs. You click right there and it'll put the vertical and horizontal asymptotes right through that point. So that's your first click with the graph making tool. And now the second click, they want us to get one other point. Doesn't really matter what other point, just one other point. So I'm just going to, we have the function y equals, minus 2x plus 6 over 2x minus 2. I'm just going to plug, just make a little xy table. I'm just going to plug in 0 because 0 is just an easy number. Any number will work, doesn't matter at all. Just going to plug in 0. And so what do we get? Well, y will equal minus 2 times 0 plus 6 over 2 times 0 minus 2. So y will equal 6 over minus 2 minus 3. So over 0 down 3, right there. Over 0 down 3. That is a point on the graph. So if you just click on the point right in the center of the crosshairs, that'll set up the 2 asymptote lines, and then you click on any one other point that the graph goes through, like 0, negative 3, then it'll produce one branch here, and then another branch right there, like this. It'll do that. Now remember, it gets super close to those asymptote lines, those dotted lines. Those are guidelines. The asymptote lines on a graph are guidelines. They're guiding the graph. The graph gets super close to those on both sides. There's also symmetry here. Do you see the symmetry? From this dot, if we go down 2 over 1, up 2 over 1, you get that same dot there. See how that works? It's symmetric. So you know it's going to be the same spot. There it is. It makes that graph for you. Number 6. Write an equation for a rational function. Rational means ratio. It's a fraction. You can see the answer down here. It's a big fraction. It's a ratio. It's called a rational function. Vertical asymptotes at negative 6 and positive 3. X-intercepts at 5 and negative 5. Y-intercept at 3. Okay. So how's all that work? Let's get a fresh place to work here. So for number 6. So they're saying vertical asymptotes, x equals minus 6, x equals 3. So those will be vertical asymptotes. Okay, So again, what makes a vertical asymptote? What makes, on a graph, that's where a graph goes up to positive infinity, y goes to positive infinity, or y, the height, goes to negative infinity. What makes that happen? Denominator equal to 0, right? Because if you have any number divided by 0, that goes to infinity. If that's a negative number, it goes to negative infinity. If it's a positive number, it goes to positive infinity. Because 0 goes into any number an infinite amount of times. So we got to make the denominator 0. So the function has got to look like this. X equals negative 6. I've got to have something here and something there, such that if you plug in negative 6, you're going to get 0 in the bottom. So that's got to be x plus 6, doesn't it? Because if you plugged in x equals negative 6, now it would make that part 0. And then over here we have to have x minus 3, because if you plugged in x plus 3, 4x right there, you would make that part 0. And if you make either part 0, they're multiplied together there on the bottom, so the whole denominator would become 0. See how I made the denominator fit this situation? I set it up so that if you plugged in negative 6 or positive 3, you would make one part or the other part 0, and since they're multiplied together, if either one of them is 0, the whole denominator is 0. When the denominator is 0, that means y is infinity, because 0 goes into anything infinite amount of times, which means there's going to be a vertical asymptote there. So it's no surprise, right? It's always opposite. See how that is? Whenever in math we put something next to x, it's always opposite in the equation, isn't it? So negative 6 here, put next to x is positive 6, positive 3 here, put next to x negative 3. We can see why, because you've got to be able to plug in that x value to make that denominator 0, so that if the bottom's 0, you get a vertical asymptote, because the whole fraction will go to infinity when the bottom's 0. So we got that part. Now, that's just the first step, though. So next, so we know that's got to be the truth. What else is the truth? Next, it tells us that the x-intercepts are at x equals 5 and x equals negative 5. So an x-intercept makes y equal to 0. Remember, that's what it means to be an intercept point. So if you have a point on a graph, like an x-intercept, it's the x-axis, that's over some number up 0. The y value is 0 at an x-intercept. That makes y 0. Remember, intercepts always mean the other letter is 0. So at an x-intercept, y is 0. So y is this whole fraction, right? Y equals that whole fraction. How do you make y, that whole fraction, 0? How do you make a fraction 0? When the top is 0. That's the only way to make a fraction 0, right? If I said last night I ate 0/3 of the pie, if I make the top 0, that's just a weird way to say you ate no pie. You can't do it by making the bottom. If you make the bottom 0, we already know that's infinity, right? 0, the bottom goes into the top infinite amount of times. So you got to make the top 0. So basically, the x-intercepts, x equals 5 and negative 5, they have to make the top 0, because that's what makes y 0. X-intercepts make y 0, and to make y 0, y is a fraction, you got to make the top 0. So what do we got to have up here? Opposite, minus 5, and plus 5, right? Because that way, if you plug in 5 or negative 5, you're going to make the top 0, you're going to make y 0, it's going to be an x-intercept. So we've got all that. What's left then? Well, they tell us, okay, so last thing is they tell us about the, let me get rid of this, about the y-intercept. So we use that to figure out if there's like a number in front here. So this is y equals, and there's some kind of constant number in front, call it a. It doesn't have an x, it's just a number, a. So I want to figure out what is that number. We've got all the x stuff done. So the x stuff is finished, but we just need to know, is there like a constant number in the front there? Call it a. Is there some number And what is that number? Well, to figure that out, they tell us the Y-intercept. The Y-intercept is at 3. And remember what intercepts mean? That's where set x to 0. Or so, x equals 0. Meaning it's the point 0, 3. X is 0, y is 3, right? Because that's what a y-intercept means. Picture a graph. If it goes through, there's a y-intercept point. Any graph that goes through a y-intercept, what's the coordinates of that point? Over 0, up some number I don't know. So x is 0, y is some number I don't know. So in other words, at a y-intercept point, x has got to be 0. So like I keep saying, at intercept points, the opposite letter is 0. So at an x-intercept, y is 0. At a y-intercept, x is 0. It's just what it means to be an intercept point. So that means we got 0, 3. We can plug that into this function. So whoop, I already didn't plug it in. Plug in the 3 there. And plug in the x. What was the x? 0. 0 minus 5, 0 plus 5, 0 plus 6, 0 minus 3. So it's a times, what is that, negative 5? Positive 5 over 6 times minus 3. And this is negative 25 over negative 18, right, when they multiply. How do you finish solving for a there? We're trying to solve for a to find out what's the value of a, the number in the front there. This is times. So you multiply, and the two negatives cancel to be positive, don't they? So you multiply by the upside down, the reciprocal, they call it, on both sides, because that'll cancel out the 18 and the 25, cross-canceling, and that'll give us a alone. So a equals 18 over 25 times 3. The 3 is over 1, so the 3 doesn't go into 25. We can't cross-cancel. So just multiply 3 times 18. What's that? 30, 25, 54 over 25, and I think they just want you to use your calculator here and get a decimal. 54 divided by 25, 2.16. 2.16, so A is 2.16, so we found it. So putting this all together then, our function is y equals 2.16, because the A goes in the front, x minus 5, x plus 5, over x plus 6, x minus 3. That's what it's got to be. You could put that 2.16 on the top of it, because it's really over 1, isn't it? You could put it in the top of the fraction, or just leave it in the front. It means the same thing either way, doesn't it? Because anything alone is really over 1, is really in the top. Same thing either way. There we go. Let's go back. So that's number 6. Let's go back to number 7. One more. There we go. Number 7. So it says write an equation for the function graphed below. So it's a lot like the last one we did. They're giving us some information about the thing. So if we look at it, we look at the picture here, we can see that it has, here's a vertical asymptote, and here's another one, vertical asymptote. And what happens with vertical asymptotes on the graph? They make the denominator 0, right? That's how a function goes up to infinity or down to negative infinity. At a vertical asymptote, it's because the denominator is 0. The bottom of a fraction becoming 0 makes the whole fraction go to infinity. So that means y equals, and in the bottom, this is what, -3. So remember, it's opposite, x plus 3, and this is what, +4, opposite -4. See, that way, if you plugged in +3 for x, or if you plugged in, -3 for x, or +4 for x, either way, you would make the bottom of the fraction 0, thus the fraction would go to infinity, and you have a vertical asymptote. So that's the significance of that part on that. Now, one special fact, though, that we've got to remember. On this one, notice let's look at -3 first off. On one side, it goes up to positive infinity, and on the other side of -3, it goes down to negative infinity. That's normal. That's what we normally expect. One side it goes up, one side it goes down, doesn't matter which side. But look at 4. Look at what it does on the two sides of the vertical asymptote at 4. It goes up on one side, and it goes up on the other. It goes up on both. What does that always mean when it does the same thing on both sides? That means this is a second power item. Remember how we learned earlier? So let me go right here. Second power. So let me fill that. Let me do this a little better. That means this term, this x minus 4, is got to be second power. Whereas the x plus 3 is just normal. This is just first power. Why? And this one is because it's just like earlier when we studied and we talked about how if a graph goes through a point, it passes through, that's first power. But if it comes up like this and bounces, that's second power. Right? Why? Because that's a U-shape. A U-shape, you know, that's second power. What makes a U-shape is always a second power. It's always a second power that does that. Why? And then, I don't know if I've ever told you more of the reason why. It's because it has to be the same sign on both sides. See how the graph is positive on this side and positive on that side? So that means that term has to be x minus 4 squared. Because if you go to the right of it, you plug in something like 5, you get 5 minus 4 squared, which is positive 1. But if you go to the left and you plug in 3, you get 3 minus 4. And you see, if it wasn't squared, if it was just first power, that would be negative 1. The graph would have to be down there, wouldn't it? But it's not. Notice the graph is up here positive. So that's got to be squared, negative 1 squared, positive 1. You see, when it's up on both sides, it's got to be a squared term that's going to make it be up on both sides. Now, having said that, I'm giving kind of a half explanation. I just don't want to use up too much time, but let me say a little bit more. If it was going down on both sides, that might be confusing for you, but that would also be squared. You might think, well, how's negative? Well, that means it has a negative number in the front, but it still would be a squared term. The point is, it's the same sign on both sides. It doesn't change its sign, which means it's got to be squared, whether they're both up or both down. Whereas this other one here goes up on one side, down on the other. It changes its sign. So that's first power. Let me prove it to you. Because again, if you put in 5, that would be 5 minus 4 squared. That would be positive times a negative number in the front would be negative. And then vice versa, if you plugged in like 3 minus 4 squared would still be positive times a negative would be a negative number. See how both sides would come out negative number? Whereas if it was first power, if this was first power, that wouldn't work because 5 minus 4 would be positive times the negative would still be negative. But the other one, 3 minus 4 would be negative times negative would now be positive. It would be different signs. So do you see how first power, so it isn't so much whether they're both up or both down. It's whether they're the same or different. Because first power makes the sign change like this one does. Positive on one side, negative on the other. That's first power. Same thing here. Positive on one side, hit, negative on the other. That's first power. But if they're both the same sign on both sides, like both positive, or even if they're both negative. If they're the same, the only thing that does that is a second power, right? Because second power makes them come out positive either way, and then if you multiply by a negative in the front, the final answer is negative, both of them. Or if you multiply by a positive number in the front, that'll make the final answer positive, both of them. Either way, they're both the same with a second power. So that's what we need to remember on these. They're going to try to trick us. So remember that. First power, when it changes, well, yeah, when it changes. When it changes, one positive, one negative. Second power, when they're both the same, positive, positive, or negative, negative. That's second power that makes that happen. So we see it at 4, it's got to be a second power term. Okay, so that's true for vertical asymptotes. That's also true. So the next thing we're going to look at now, having done all that work, now let's look at this point. There's an x-intercept. That's where it hits the x-axis. At x is 2, it hits the x-axis. So what? Well, that means that's the point 2, 0. X is 2, y is 0 at that point. So in other words, when you plug in x equals 2, y is 0. How do you make y 0? Y is this whole fraction. How do you make it, right? Y equals that whole fraction. How do you make a whole fraction 0? By making the top 0. The only way to make a fraction 0 is to make the top 0. So this means top equals 0. So that means we have x, remember it's always opposite, minus 2 on the top. Because that way if you plug in x is positive 2 there, you make that top 0, you make the whole fraction 0, y is 0. It fits with the point 2, 0. Makes sense? Now, is that a first power term or a second? Well, it changes sign. It's negative here, positive there. So on the two sides of that location, it changes sign. So that's just a first power term, isn't it? If it bounced both down or both up, then it would be a second power term, just like the two sides of a vertical asymptote. It's important to remember that. Okay, so now, last thing is we need to worry about that number in the front. Let me back this up a little bit. Back up the bus here. Y equals A. So there's some kind of A in the front, which we have to now find. How do you find that A in the front? Well, that's going to come from this point, the Y-intercept. So see how we use the vertical asymptotes to find the denominator stuff, and then we use the X-intercept to make the top 0, the numerator stuff. So we get the denominator stuff from the vertical asymptotes, the numerator stuff from the X-intercept, and then the Y-intercept, the Y-intercept 0, negative 2, you use that to find your A. So let's do it. Let me go back over here. And I'm going to find my A. Let me get rid of some of this stuff here, so we have a little bit of room. So let's find our A. So this is X and Y. So plug in Y is negative 2. Plug in X is 0. 0 minus 2. 0 plus 3, first power, and then 0 minus 4, second power. So that becomes minus 2. Let me change the color here. So minus 2 is A times what? Minus 2 over 3 times 16. Negative 4 squared is positive 16. So minus 2 is A times, well, I guess 2 goes into 16 8 times. So that'll be negative 1 over 24. See, I reduced that fraction. 2 went into 16 8 times. 3 times 8 is 24 in the bottom, leaves me with negative 1 on the top. So how do you finish solving for a there? Multiply by the upside down, the reciprocal on both sides. 24 over negative 1, cross cancels all that out. A is alone. On the other side, 2 negatives makes positive, and 2 times 24 is 48. Positive 48. So there we go. That's our A. So the final answer to this one is going to be 48. That's our A, right? 48. X minus 2 on the top over x plus 3 times x minus 4 squared. And you can put that 48 in the front or leave it in the top. It's the same thing, right? To be in the front is over 1 is the same as the top. Either way is good. So recapping again, vertical asymptotes tell us the denominator. X-intercept tells us the top, the numerator. And then the Y-intercept helps us find the A. That's how we do it. All right, let's try number 8. Similar kind of thing here on this one. Okay, I did one thing. Well, let's start with the verticals. So vertical asymptote, that tells us what makes the denominator 0, doesn't it? Because a function only goes down to negative infinity or up to positive infinity when you make the denominator 0. So that tells us that y equals, and then this is negative 3, so it's opposite, x plus 3. This is plus 4, so that's minus 4. And now, is any of these, this one is first power because it's positive infinity on one side, negative infinity on the other. It changes signs, so that's first power for that guy. This guy, it's negative infinity on both. So that's second power, isn't it? The only way that you're going to get those to be the same is if that's second power. We talked about that a lot in the last problem. If you missed that, you want to hear more of a discussion on that, go back to problem 7. Okay, so now how do we do the top? What's going to tell us about the top? The x-intercept. It's hard to tell on that graph. It's right there. So the x-intercept, 2, 0, x is 2, y is 0. This tells us about the top of the numerator, specifically x minus 2, opposite, right? Because if you plug in x is 2, positive 2, it makes 2 minus 2 is 0. It makes the top 0, which makes the whole fraction 0, which makes y equals 0. Y is 0. So that tells you the top. So the vertical asymptotes tell you the denominator. The x-intercept tells you the numerator, the top. And then finally, we have to find the A in the front or the top, however you want to place it. How do we find that? Well, this one goes off the screen. It's over here. It goes off the screen. It should say the y-intercept is 0 minus 0.2. 0 minus 0.2. That y-intercept is how we find A, is with the y-intercept. You can see it hits right here, but it's hard to tell exactly where that is. They're saying that 0 minus 0.2. They tell us explicitly. So we use that to find A. So plug in that information. So this is our x and our y. Our x is 0 and our y is negative 0.2. So plug in y as negative 0.2 and plug in x as 0. Okay, so what do we got here? Bring this down. Negative 0.2. This is A times negative 2 over 3 times 16, because negative 4 squared is 16. And so that's negative 0.2. 2 goes into 16 8 times, so that's A times negative 1 over 24, just like the last problem. And so how do we finish getting A alone? multiply by 24 over negative 1, the reciprocal, 24 over negative 1. Cross cancels out here. A is alone. Use your calculator. Just take 0.2, so that the two negatives make positive. Just take 0.2 times 24. You'll get, whoops, I just realized I made a mistake. Probably you've realized it too. Sorry. Back here, this is supposed to be second power, isn't it? Because at this x minus 2, it's second power because it bounces there. Right? It bounces. It doesn't pass through. It's the same sign on both sides. Both are down. So remember that difference? I better remember. If it passes through, that's first power. But if it bounces, that's second power. I forgot right there. Just like with the vertical asymptotes. Right? If it's the same sign on both sides, if they're both up or both down, if it makes a U shape, it's second power. That's why with this vertical asymptote here, these are both going down, negative infinity. That's why this guy was second power. Well, same thing here at this x-intercept. This is going down and this is going down on both sides of that x-intercept. So that should have been second power back here. So that's going to change this. Sorry about that. Bring it on back here. It's going to change things a little bit. This should have been negative 0.2. This is A, then negative 2 second power would be 4 over 3 times 16. And then 4 goes into 16 4 times, so that becomes negative 0.2 is A over 12. How do you finish getting A alone there? Multiply both sides by 12. Cross cancels because 12 over 1, huh? So A is minus 2.4. So we got our A. So I got a little bit tricked there. All right, so what's the final answer then? A goes on the top, which is, let me erase this infinity here, which is Y is negative 2.4 times x minus 2 squared over x plus 3, x minus 4 squared. It's easy to mess up like I did and forget about the second power. So we really have to remember for vertical asymptotes and for x-intercepts, if they bounce, if they're both down or both up at a vertical asymptote or x-intercepts, then that's second power. Whereas if it's, one side up, the other side down, that's first power. It passes through. One's negative, one's positive. That's first power. But if it bounces, or both are down, or both are up on the two sides of the vertical asymptote or x-intercept, that's second power. All right, those are tricky problems. All right, on to number 9. So this is number 9. It doesn't say the number there. There we go. So this is number 9. Select the choice that is a graph of the function. So we're doing it backwards. Now they're starting us with the function, and they want us to pick the right graph. So let's go through it. Multiple choice, pick the right graph. So how does this work? Well, the denominator, so that would be x is negative 2 and x is positive. Those will make the denominator 0, won't they? And when you make the bottom of a fraction, this is y equals here. If you make the bottom 0, those are vertical asymptotes, because if you make the bottom 0, if y equals anything over 0, that goes to infinity or negative infinity, depending on if that number is positive or negative. It'll be positive or negative infinity, because 0 in the bottom goes into any number an infinite amount of times. So whatever makes the bottom 0, those are vertical asymptotes. So at negative 2, right there, and at positive 2, right there, we should have vertical asymptotes. So that looks right, that looks right. It's doing that good. Let's look at the other two answers. Negative 2, positive 2, negative 2, positive 2. Well, they're all looking pretty good. That didn't really eliminate anything. They definitely are right on that. They have vertical asymptotes at -2 and +2. Notice they're both first power, aren't they? First power, which means it's going up on one side, down on the other, up on one side, down on the other, up on one side, down on the other, up on one side, down on the other. That all looks good. Same thing over here. Down on one side, up on the other, down on one side, up on the other, right? Down on one side, up on the other, up on one side, down on the other. Yeah, they're all looking good. They're all first power. None of them are second power. In other words, it's not going to be both up or both down on the two sides of the vertical asymptote. Okay, so that didn't really eliminate anything. Let's go to the top. What do you plug into the top to make it 0? +1, right? Plug in +1 to make the top 0. And if you make the top of a fraction 0, it's just 0. If I ate 0/3 of the pie last night, that's just a weird way to say I ate no pie. So x equals 1, +1, goes with y0. It makes the top 0, which makes the whole y, because this whole thing is, f is y, really. Function values are y values. The whole thing equals 0. So that means the point over 1 up 0 has to be on the graph. That's the x-intercept point, isn't it? So that'll help. Which of these have the point over 1 up 0? Over 1 up 0? No. Over 1 up 0? Yes. That one looks good so far. How about on the back? Over 1 up 0? Yes. Over 1 up 0, no. Okay, we've eliminated 2 of them. We're down to 2 more. We have 2 more to go. It's either this one or it's this one. How do we know which one it is? Well, notice they have a different y-intercept point, don't they? This one has a y-intercept of -1. So notice how we start with the vertical asymptotes, which is what makes the bottom 0. Then we go to what makes the top 0, which is the x-intercept. And then finally we use the y-intercept. So we use the vertical asymptotes, the x-intercept, and the y-intercept. So what's the real y-intercept? Well, y-intercept means set x to 0, right? Opposite letter 0. So take this equation, y equals 4, x minus 1, over x plus 2, x minus 2, and plug in x is 0 there in the other 2 spots and see what you get. That'll be 0 minus 1 over 0 plus 2 times 0 minus 2. So that'll be what? 4 times -1 over 2 times minus 2. And that's 4 times -1 over -4. And 2 negatives is positive. 4 over 1 times 1/4, they cancel. Y is 1. So it should be 0, 1 is the y-intercept. The y-intercept is right. We made x 0, and that led to y is 1. See what happened there at the end? The 2 negatives made positive, and the 4's canceled. So 0, 1. So which one has it? Is this 0, 1? No, it's 0, -1. That one's a no. And this one's 0, 1. Yes, there is the right answer. So that was tricky. So we used, again, we started with the denominator. Whatever makes the denominator 0, those are vertical asymptotes. Because if you make the bottom of a fraction 0, it goes to infinity. And then we looked at what made the top 0. To make the top 0, the whole fraction just equals 0, so y is just 0. So x equals +1 went with y 0. 1, 0 had to be a point in the graph, the x-intercept. Then finally we looked at the y-intercept. Intercepts are always opposite letter 0, so y-intercept meant x 0, plugged in 0 for x, solved for y, 0, 1 had to be on the true graph. There we go. To number 10 we go. So on this one, they want us to find an inverse function. An inverse function. So how do we find an inverse function? Remember the steps. To find an inverse function, step number 1 is you invert x and y. So here's y out here. Let's just swap x and y. So we get x over here and y over here. So I switched x and y. Step 2, solve for y. So you invert x and y, and then you solve for y. So how am I going to solve for y? Well, we've got to subtract 6 from both sides, if I can squeeze that in there. I'll cancel these out. Let me bring this down, x minus 6. So what do? We're trying to solve for y's over here, saying I want to be alone, get rid of all this stuff. So how do we get rid of that root? 2 power. Parenthesis 2 power both sides, and the 2 power cancels the root, doesn't it? So we get 4y minus 9 is x minus 6 squared, and then we add the 9. We're trying to get the y alone. Add the 9 to both sides. And so 4y is x minus 6 squared plus 9. And whoop, did the wrong thing there. And we're almost done. Last step to get y alone, divide by 4. Boom. This is the opposite function from the original. And that, in fact, is the answer they have there. That's the inverse function. It looks the opposite, doesn't it? Instead of a root of 4x minus 9, it's second power. Instead of the 6 being added, it's subtracted. Instead of the 9 being subtracted, it's added. Instead of multiplying by 4, it's dividing by 4. See how that's the opposite function? It's the inverse function. Okay, let's do number 11 on a fresh sheet. Same kind of thing. They want us to find the inverse. So I'll do number 11 on a fresh sheet back here. So number 11 is f of x equals negative x plus 1 over 3x minus 4 to find the inverse. So how do we find an inverse function? Step 1, you invert x and y. And this is y right out here. So we trade spots, right? The y's become x's, the x's become y's. So we get y equals minus, not y equals, that's x. We get x equals minus y plus 1 over 3y plus 4. Okay, and then step 2, solve for y. So switch x and y, invert x and y, solve for y. So how do we solve when we have a fraction on one side like that? You know what to do. You put this over 1, you go diagonal, diagonal, right? So x times 3y plus 4 is 1 times minus y plus 1. Distribute. 3xy plus 4x, distribute, minus y plus 1. Now, what do we do to solve here when we have, see how this term has a y and that term? We're trying to get y alone, and 2 terms have y's. Remember what we do? I'll write it over here on the left. We have to get the y's on the same side. So I'll jump this guy this way, this term, and then I'll jump this guy that way. So we get 3xy plus y. Remember, when things jump to the other side of the equal sign, it changes signs. And this will be minus 4x plus 1. And then, what do we do next? Factor out the y. So factor out the y like that. And then you know what to do from there, right? Just divide it. 3x plus 1, 3x plus 1. Boom. There it is. There's the inverse function. And let me mention that there's other ways on the multiple choice test. Would you recognize that these two answers are the same? Because on multiple choice test, they could have it either way. those are the same thing. Would you recognize that? Why? How do we know those are the same thing? Because if you just take this answer here and you multiply the top and the bottom by -1, boom, 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 you get that one. So whenever you multiply top and bottom of a fraction by -1, you're not changing it, right? If I take 2/3 and I multiply top and bottom by -1, -2 over -3 is the same thing, right? 2 negatives makes positive. It's a different way of saying the same thing. So whenever you multiply top and bottom of a fraction by -1, what you get is another way of saying the same thing. So whenever you get an answer on an exam, a multiple choice exam, if you look at the options and one of them is exactly the same but all the signs are opposite, that means it's the same answer. Grab it. They just multiplied top and bottom by -1. Well, they didn't try to trick you. They just happened to solve it a different way and got it looking that way is all that happened. All right. Oops, let's go on to number 12. Go back here to number 12. There it is. Okay, number 12. The fox population in a certain region has an annual growth rate of 6% per year. The population in the year 2000 was 8,000. Find a function that models the population t years after 2000. Okay, and use this function to estimate the fox population in the year 2008. Okay, so let me go back where we have some room to work again, and I'll work it out here. So number 12, I'll give you the relevant facts. The fox population annual growth rate is 6% per year. In the year 2000, the population was 8,000. Okay. So I need a formula. So generally, how we do these formulas, how's this going to work? Well, it's always going to generally be like this. It's going to be y equals a times b to the x, or t, whatever, t for time, or y equals a, and instead of the b, you can put 1 plus r to the t when a rate is given. So it's useful to use. So there's two different forms we can use. This or this. These are exponential growth formulas. So it'd be good to put these on your sheet of notes for the exam. Exponential growth formulas. Put this on your card for the exam. So basically, it's exponential because the variable, the t, is up in the exponent zone, the power zone, right? It's exponential. And there's two different forms. So when something has an annual growth rate, if they give you the rate, then it's better to use this one that has the rate in it. So I'll use that one. And so we have y equals a 1 plus, and the rate, 6%, make that a decimal, 0.06 to the t. So that means y equals, well, I'll bring it down, a times 1.06, right? 1 plus 0.06 is just 1.06 to the t. Okay, so where's t? Now, what is t? T is time after. Now, it says right in this problem, they want you to let t be time after the year 2000. So time after the year, in other words, t equals 0 in the year 2000. So they always do this in these science problems. They always have a starting point. In this case, it's the year 2000. They want that to be time 0, and then everything is measured from there. So now I'm going to plug in the information. They're saying in the year 2000, population was 8,000. So in the year 2000, in the year 2000, which means time is 0, right? Time is 0 in the year 2000. The population Y is 8,000. So I take this Y and I say, all right, Y, you are 8,000 when the time is 0. So what happens there? What's anything to the 0 power? 1. Do you know that? Make sure you know. Any number to the 0 power is 1. So this just means A is 8,000. And that makes sense. That A in the front, this A that's, right here in the front of either version of the exponential growth formulas, the one without the rate and the one with the rate, depending on whether they give you a rate or not. The A in the front, that's always the starting amount, right? Because it's when time is 0, all you'll have is A. So there we go. So our formula now is Y. So the answer to part A, where they want the formula, is Y equals A, which is 8,000, right? This A is now 8,000. 1.06 to the T. That's what they're asking for in part 1. They're saying, find a formula. So there we go. Now, coming on down to part B, now that we have this formula, they want me to use this formula. To do what? They want me to use this formula to estimate the fox population in the year 2000. So they want the fox, 2008. Did I say the wrong thing? Fox population in the year 2008. So in 2008, that's time 8, remember? Time is after the year 2000. It started in the year 2000, so 2008, that's 8 years later. So plug in T equals 8 to that formula. So plug in 8. Boom, right there for T, right where T goes. All right, hit the buttons on your calculator. So you got to do 8,000, and you got to go 1.06 to the power 8. You might have a power button X to the Y or up arrow, something like that. Hit equals, and you will get a fox population 12,750. On that, it's actually, let me see, it's actually 12,750.78. I guess they want us just to round down. I don't know why we didn't round it to 12,751. I don't know. They didn't really say, but I guess they want me to round down. It's all just an estimate anyway, right? You don't know exactly what the fox population is going to be, but this generally estimates the growth of the fox population. There we go. So they rounded down for whatever reason. I don't know why they didn't say. All right, so back to number 13. Number 13, a vehicle purchased for $25,000 depreciates at a constant rate of 9%. I mean, depreciates means it goes down in value. That's what happens if you buy a car, especially if you buy a brand new car. The minute you drive it off the lot, it starts losing value because it's no longer brand new. It's used, and year by year, your car loses value, actually pretty quickly. Cars are known to be a very bad investment. They're fun to drive, and you need them for life, but as far as like an investment, they're not usually very good investment. They lose their value really quick. They depreciate. They go down in value. Unlike a house, a house goes up in value over time, but cars drop in value. Anyway, so constant rate of 9%. So determine the approximate value of the vehicle 12 years after purchase. So this one is going to be a lot. I bet we can squeeze it in right here. It's going to be Y equals A1 plus R to the T again, right? It's the exponential growth formula where they have a rate. And then we're going to remember what the A is. The A is always the starting amount. So what's the starting amount? $25,000. And the R is 0.09 to the t, so that's 1.09. It's a funny looking 9 there. 1.09 to the t. All right, and they want it 12 years later. So plug in a time 12. They want to know the value of the car. Oh, wait a minute, I made a mistake. This is going to be minus because it's going down. Yeah, so it's plus. The rate is, I should have said plus or minus here. Yeah, so back in that other formula, when I wrote it, well, I won't go back. Whatever, you get it. So it's plus or minus. Minus for decrease. Plus for increase, minus for decrease. So this would actually become 0.91, right? $1, take away 9 cents is 91 cents. 0.91. So 0.91 to the t. T is 12 years. And so there we go. Hit the buttons on your calculator. And I'm getting 8061.88. Round to the nearest whole number. So we will say 8062, 8062. So your car drops from $25,000 value to only a little over $8,000 12 years later. So that's what happens to cars. So there we go. So whenever they give us a question and there's a rate, a constant rate. So these last two problems, the Fox problem, it was a growth rate. So that was growth. So that was A1 plus 0.06 to the t, because growth means increasing. And this one, number 13, was a depreciation, so it was a negative growth. The rate was negative 0.09. So we use this formula whenever they give us a rate of growth or decreasing, increasing or decreasing. It's positive for the increase, negative for the decrease. There we go. 14. An exponential function passes through the points 0, 3 and 3, 192. So what are the values of a and b? So they're giving me this kind of a function. So y equals ab to the x. And it's just a matter of plugging in some information. They're telling me x is 0, y is 3. So plug in y is 3, x is 0, first off. And then remember, what's anything to the 0 power? That's 1. So that tells us a is 3, so we got a. Now let's use it again. Y, start again, come back up here. Y equals ab to the x, and now we know from part 1, we know what a is. That doesn't change. We keep that information now that we have it. We keep the fact that a is 3. We know it, and we'll use it. And now in part 2, we have another xy. We're going to plug those in. So y is 192. X is 3. So now we're going to solve. They want b. We're going to solve that for b. B's over here saying, I want to be alone. So how do we solve that for b? Our first step, divide both sides by 3. And we get 192 divided by 3. I'm getting 64. Okay, now, how do we finish getting b alone there? We got to get rid of that third power. What's going to do that? You have to raise both sides to the 1/3 power. Right? These cancel. Now, on your calculator, take 64 to the power 1 divided by 3. And you can, the power button's either X to the Y or up arrow or something like that, depending on your calculator. You got to put parentheses around the 1 divided by 3, and you'll get the answer 4. So the answer for B is 4. So make sure you go to the power 1 divided by 3, and you'll get that. All right, let's try number 15. So number 15, they're giving us a bunch of different graphs here, and they want us to figure out which one is which one. So this is a little tricky. Okay, this actually shouldn't be too bad. Basically, what we have to remember when you have an exponential, these are all exponential functions because x is up in the exponent zone, right? X is an exponent. These are exponential functions. And so basically, you need to remember a couple things. First off, the a is where the graph starts at x equals 0. In other words, it's the y-intercept. Because x is 0 is the y-intercept. What y? Because if you plug in 0 for x, you see what you get? What's b to the 0? What's anything to the 0 power 1? So y just equals a. So you see, when x equals 0, y will just be a. So what a is the value of y when x is 0, isn't it? That's what that a in the front is. It's the value of y. It's the height when x is 0. It's the height when x is 0. So that means it's this height or this height. When x, this is the x-axis here. When x is 0, it's the height. So this one's up at, what's this, 3, and this one, these, all the rest are up at 2. So which one of those graphs has a 3 in the front? Well, this one right here. That's got to be the black one, doesn't it? That's got to be the black one. Okay. All the other ones start at 2, so we're going to have to distinguish them out. So how do we do them? Well, they're all about that other number, the b. So the b, if the b is greater than 1, it grows. It goes up to the right. And if the b is less than 1, it decays, we call it. It goes down. Goes down to the right. All right, so let's see this blue one right here. This is, or purple or whatever it is, a blue one. It's going up to the right really fast. So it's got to have the biggest number. That's this one right here. That's got to be the blue one. It's got the 1.45. That's the biggest number there. And now the green one is also going up to the right. So that's this one. That's the other one that's greater than 1, bigger than 1. That's got to be the green one. The other two are less than 1, so the orange one here and the red one. So the orange one and the red one's the smallest number. So we could do that one easy. The red one's right here. 0.68 is the smallest. That's got to be the red. And then the orange is right here, the 0.85. It's less than 1. It's going down to the right, but it's not as small as the red one. There we go. That wasn't too bad. So it's all about knowing the a in the front is where the graph starts when x is 0. It's the y value when x is 0. And the b tells you about the growth if it's greater than 1, or the shrinking, the decaying, goes down to the right if it's less than 1. It's all about that number being more than 1 or less than 1. Remember, because we said it was 1 plus r, that, you know, we wrote the other version of the formula. We wrote it as a, and we wrote it two ways. It's a times b to the x, or t, whatever, same thing. Or you can replace that b with 1 plus r. So you see, if that r is a positive rate, this number will come out more than 1. If it's negative, if that rate is negative, this will come out less than 1 and it'll decay. That's another way of seeing that. Okay, so number 16. So now we're looking at negatives and stuff like that. Well, let's start with y equals just plain old 2 to the x. If you made a quick little xy table for this one, you put in 0, 1, 2, what would you get? 2 to the 0, anything to the 0 power is 1. 2 to the 1 is 2. 2 to the 2 is 4. So that one goes over 0 up 1, over 1 up 2, and over 2 up 4. So it's going up like that. And remember, exponential graphs, they always rocket on one side, flatten on the other. So which one looks like that? Well, that's clearly the orange one here. So the orange one is the A, is the 2 to the x. All right, now, what's going to happen with the other versions? So we got that one first off. What's going to make the graph, what's going to make the blue thing happen where it goes down to the right like that? What's going to make it shrink down to the right? Well, how about this? Rather than just go after the blue, let's just take them one at a time. Let's take this right here, and let's do that one, just see what he does. Minus 2 to the minus x. Just plug in xy table. Again, just do 0, 1, 2. See where the thing's going. If you plug in 0, you get minus 2 to the minus 0. That's minus 2 to the 0. Anything to the 0 power is 1. That's minus 1. Now plug in 1. That's minus 2 to the minus 1. Now, you have to know, what does a negative power do? Do you remember that? It flips it. And remember, negative powers, they're not the same as negatives in the front. Very, very different. Negative in the power zone is totally different than negatives in the front. They mean that the graph is up, it flips the fraction. Remember, negative is unhappy is the analogy I try to give you to help you remember. It's unhappy where it's at. It wants to flip to the bottom. Finally, what if we plug in the 2? 2 to the minus 2, it's 1/4. Right? Because again, let me straighten that out. Negative powers, this negative power here, flips to the bottom and then becomes positive. So you need to remember, negative powers flip to the bottom and then become positive, and that's negative 1/4. Negative 1/4. Okay, so what does that look like? Let me erase this and draw a little bit of a graph here. What is that one going to do? So we've got 0. Oops, so it's over 0, down 1. Let me make that a little bigger. Over 0, down 1. Over 1, over 2. Over 1, down 1/2. Over 2, down 1/4. It's only down a little bit. See what it's doing? It's going like that. It's flattening on that side, so it must rocket on the other. Remember, exponential graphs always flatten on one side, rocket on the other. So which graph is that? That's the red one here, isn't it? So that's the red one, like that. All right. What comes next? Let's try the, come up here and do the negative 2 to the x. So this is y equals negative 2 to the x. Make an xy chart. 0, 1, 2. So if you plug in 0, whoops, forgot the negative there. Negative to the 0. Remember, anything to the 0 power is 1. And 2 to the 1 is negative 2. And 2 to the 2 is 4, right? 2 squared is 4. It's negative 4. By the way, that's not, you might wonder, isn't that positive 4, Mr. Heron? No, it's not negative 2 squared like that. That would be positive 4, because then the negative gets squared, and 2 negatives makes positive. But here, it's only the 2 being squared, not the negative. There's not 2 negatives, so it doesn't become positive. I'll say it's not this. All right, what's graph look like? Let's graph that thing. So over, let me do a little bit, need some room in the negative direction. Over 0, down 1. Negative 2, negative 3, negative 4. Over 1, down 2. Over 2, down 4. So it's kind of rocketing down this way, so it must flatten the other side. Remember, the exponential graphs always rocket on one side, flatten on the other. So which graph is that? Clearly the green one. That's the green one. So that's D, the green one. And what do we have left? The blue one. B, this must be the blue one. We can prove it real quick down here. Prove it's the blue one. So that's the equation 2 to the minus x. So we do xy chart. Again, I'm just going to do 0, 1, 2. If you plug in 0, 2 to the minus 0 is just 2 to the 0. Anything to the 0 power is 1. plug in 1 now. 2 to the minus 1. Remember, negative powers are unhappy where they're at. They jump to the other side. It's a half. And then negative 2, it's unhappy. Negative power, unhappy where it's at. Jumps to the other side of the fraction, then becomes happy. Jumps to the new job. Now it's happy. 1 over 2 squared, 1/4. There it is. So what is the graph of that one? Let me erase these. And we'll do the graph. So over 0 up. I'll make that 1 right there. Over 0 up 1, over 1, over 1, up a half, over 2, up a fourth. It's going down, down, down to the right, which must mean it rockets on the other side. They always flatten on one side, rocket on the other. Sure enough, that's the blue graph. There it is. We got it.